and live. See if this preview window comes up. There it is. All right, perfect. Let's go ahead and get ourselves set up. That's not what I wanted. I need a little bit more room to see things. All right, so chat over here, main window over here. Let's get our code set up too. All right, so that gives us all of our code. From last time, we do have a running web server. It doesn't do much. I mean, it just sends back this this index to HTML. Also, no matter what route we're on, which is not necessarily the best actions for a web server unless we're making a single page application, but we're not, of course. Let's go ahead and get to the book. All right, so continuing on, we're at validating the request and selectively responding. Right now, our web server will return the HTML in the file, no matter what the client requested. Let's add functionality to check that the browser is requesting / before returning the HTML file and return an error if the browser requests anything else. For this, we need to modify handle connection as shown in listing 20-6. This new code checks the content of the request received against what we know a request for / looks like, and adds if and else blocks to treat requests differently. So looks like what we're gonna do is function handle connection. We get the stream, we create the buffer, we do all that stuff. Let get, so it's basically a get is gonna look like this. And notice we have the B here. This is gonna convert it to bytes. So let's do that. In fact, you know what would be really easy for this is to run the server. So cargo run. So it's running right now. We don't have anything like telling us that it's actively listening. Let's then hit it with localhost 3000. We get our hello from Rust, and here it is. Get HTTP 1-1. So we'll copy this, and now in our code, we can say, okay, so we have our stream, we have our index. We can also say, let get index or get root equals, and it's going to be B and that. So now we can maybe break this apart by new lines. Good morning, Stacking. Hope that you've been having a good time with Rust. see. We want that. Let's go back and take a look what we want. So we end up having this now. Oh, they need the /r/n, so I forgot about that. /r, /n. If buffer starts with get. Oh, that's interesting. So we want to say if this is the first thing, which it does look like it is. So if buffer, where are we putting it? Okay, right here, stream read buffer. This is some low-level web server. Yeah, no, it is. It's from scratch, no libraries. That's what it looks like, at least. Okay, so we're gonna get our root. We don't even need to pull this in, so we need to do this right here. So if buffer dot this is starts with, oh, look at that, it doesn't have it. So it starts with, and then we pass in get root. Okay, so if the buffer starts with root, well, minus the library handling the TCP connection. Well, we didn't pull this in from, well, okay, we're using the standard library, and that's it. And the standard library is very small, so that does make it very low level. Okay, so if the buffer starts with this get root, then we want to pull in this index.html. We want to set the response to be this, and we want to write the response out. You know, if I want to make this handle multiple things, what I probably want to do is up here, just like initialize some variables. So for example, let HTML and let response, like that. Then this can be just using them. So response is being set. This is going to be just HTML. Then here in stream write the response, I guess if buffer starts with get root, we want to do this. Oh, right, because this is possibly uninitialized. We need a 404. So then we can have an else. And this is going to have to be the same thing, except we're going to some minor changes to it. So HTML is read. Let's call this 404.html. And response is going to be 404. Then we're going to stream write the response and print line. Okay, so that's all good there, which now means we need a 404.html. Oh man, this terminal is so slow for me. Touch 404.html. Would a 404 still be an OK status? No, it literally would be a 404. And that's for the automated systems to pick up like whether or not it couldn't find it. Wandable is now hosting me. Thank you very much, Wandable. Let's see. Touch 404. I guess need anything else in there. So let's go ahead and write our 404. So There we go. This one's going to be not found. We'll do an H1. I'm sorry, but we couldn't find what you are looking for. Okay, so the idea is that now if we come to this, if we start our server up again, then we're going to hit this this 404 if we don't hit a normal one, and that allows us to be sort of very generic with which one we're getting, and we only have to write the stream 1 once. Let's well, there's more to do here, I bet. Okay, stream write. We're doing the stream flush. No, we're not. We added the stream flush. Whoopsie whoopsie, I couldn't find what our server was looking for. We have a web monkey look. Oh yeah, is that's not GitHub. Is it Netflix or one of the other ones has a really good 404 page that looks like that. But I'll put this one in. That's a good one. It's every day nowadays, make it running a meme. That is true. You can put some nice CSS on it, make it like spin too, because why not? Okay, so we have the stream right, but what we're not having is the stream.flush.unwrap. So we've added that. So let's add that here. So stream.flush. Usually, when you're flushing something, it's like sort of sitting in memory, and you want to like make sure it gets written out to disk or actually sent out before it continues running to the next line. Just in case like we're running, I'm guessing that we're going to be running a loop for this, and we want the flush to make sure that it really sends this out before we potentially take care of the next connection. All right. First, we hard code the data corresponding to the slash request into the get variable. Because we're reading raw bytes into the buffer, we transform get into a byte string by adding the b quote byte string syntax at the start of the content data. Then we check whether buffer starts with the bytes in get. If it does, it means we've received a well-formed request to slash, which is the success case we'll handle in the if block that returns the contents of our HTML file. If buffer does not start with the bytes in get, it means we've received some other request. We'll add code to the else block in a moment to respond to all their requests. Run this code now and request, 127.001. You should get the HTML and hello.html. If you make any other request, you'll get a connection error. Well, except for us, we will get a 404 page. Now let's add code. Okay, so let's not do that yet. Let's go test our server. Okay, so running. Oh, it did the wrong one. Okay, so hello from Rust, that's perfectly acceptable. And if I go to anything else, I get the oopsie whoopsie. That's our 404 page. It loads up just fine. So if you get to a 404 page, you should be able to go to the network tab, hit the request, and then see that we're getting this 404 for everything. Interesting, it's looking for a main.js for some reason, a main.css, anything. Is my HTML looking for those things? No, I didn't put any CS code. The autocomplete from VS Code put in main.js. Oh, ew. Okay, we don't need Go away. We don't need styles. I should not need to restart the web server for this. It should just, yep, it just works just fine. I don't know why, like I auto-completed from VS Code for the index.html, so it should have been exactly the same, but it apparently was not. Now let's add the code in listing 20-7 to the else block to return a response with the status code 404, which signals that the content for the request was not found. We'll also return some HTML for our page to render in a browser, indicating that the response to the end user. So let's see how they do that. They have this else status line. So they're doing the same thing that we are, except for the fact that they're having a stream write and stream flush inside of each of the if and the else's. So I'm curious about whether or not let response equals format this status line contents. Am I doing that? Oh, that's interesting. So they're basically creating a status line here. So as a separate string, so they can just do response equals this. And format it down here. So stream write response as bytes dot unwrap. That should still be fine. It's basically this. Although I guess maybe what would be better is to put something like let status equals 404. No, this is 200. This will just become like that, and we'll put in a status. We'll do the same thing here. That status equals 404. So that should then include it all together. So what status we're getting. That should be nice. Here response has a status with line with status code 404 and the reason phrase not found. We're still not returning headers, and the body of the response will be the HTML in the file 404.html. You'll need to create a 404.html file next to hello.html for the error page. Again, feel free to use any HTML you want or use the example HTML in listing 20-8. So ours is much more fun than this one. With these changes, run your server again. Requesting localhost should return the contents of hello.html. And any other request, like to foo, everybody loves using foo. It's a bit overused, I think. Should return the error HTML from 404.html. A touch of refactoring. At the moment, the if and else blocks have a lot of repetition. They're both reading files and writing the contents of the files to the stream. The only differences are the status line and the file name. Let's make the code more concise by pulling out those differences into separate if and else lines that will assign the values of the status line and the file name to variables. We could then use those variables unconditionally in the code to read the file and write the response. Listing 20-9 shows the resulting code after replacing the large if and else blocks. I'm curious where the whole foobar thing comes from. Anyone? I vaguely remember in classes a long time ago reading that foobar came from like military statements, but I don't really remember for sure, so that's may or may not be accurate. Okay, so before I didn't read that that block. So what I'm thinking of, we have our get root. Kind of want to do like a base. maybe I can have like a, so okay, so we have we're creating HTML, we're creating the response, we're initializing our buffer, we're reading the buffer and getting it out. Get root for here. So this is sort of like creating a, like what path we're on. It's like, what is the current path that we need? I wonder if, well, I guess, okay, so it starts with get root. I wonder if I could like name this for just app.get slash. I mean, sort of like in Express, I can just do like app.get slash, and it's doing this behind the scenes. I wonder if I can create a function that will, I can pass in this part right here, and it'll give me this. So instead of something full like this, I could call a function, for example, like create like create path. So path, and we're gonna pass it in string slash. Starts with path slash, which means of course we need to create a function path. We're gonna take in a what, I guess it's gonna be location, and this is going to be a type stir, and we're gonna return a we should probably just return a full string. You could just turn it into an enum or a struct. Ooh, enum and struct can do a match statement on a route handler to make it much easier, but then we were going really off the beaten path. Yeah, no, that would probably be the next step, would be an enum that is only things like root would be this. Well, maybe. I guess I could like define it as that, because I don't know if that's exactly the right type. The problem is I'm matching strings. And so I can hard code the string in, but I want to make it a way so that this can be a little bit easier to handle with. I'm going to start with this, and maybe in the future we could think about a better way to do it. Okay, so path location string. The trait bound standard marker size is not satisfied. Stir does not have a constant size node at compile time. The trait, okay, so maybe I can take a reference to stir. And now it's just yelling that I'm not actually returning the string. So what I want to return is format. Well, what I want to do is take this. Oh, bytes. How do I tell what I'm returning byte-wise? As bytes. Can I say this? Cannot find type byte in this scope. All right, let's try not telling it what we're going to return. We will return it, and then it will yell at us, depending upon what we have. That's a good one, right? Okay, so we want to return this entire string as bytes. I think a byte is a U size, but I'm not sure. Ooh, that might be good. Let's try this. So I want to essentially format, but that will create a string, but then I can return as bytes. So can I say format like this? Oh, why do you get rid of that one? VS Code. Okay, there we go. You are there. I'm going to put in the location as bytes, like that. Cannot find bytes in this scope. As usize. Okay, so this is basically saying, hey, we're returning and we shouldn't have returned. And this is saying mismatch types, expected reference to U8, expected type, string size of U, so like a vector of U8s. Can I do as bytes? Mismatch types. Aha, expected empty found reference to U8s. Okay, so let's see if the U size works. I'm guessing it doesn't. Because now it's saying expected U size found. Okay, so I need to say reference U8. Borrowed value does not live long enough. Oh, so that's the problem. I can't really. I can respond with this and send back a string. If I do that, it's a full string. Then in here, so we're going to call path, we're going to get that, but then I have to do as bytes here to sort of make that really work with that. Which it's a little bit annoying, but it's, I guess like the next thing would be to potentially pass in, yeah, it's probably like to use some kind of enum or something else, calculate what it is that we're on, and then call a specific function and recreate, like essentially express. But I don't need to like recreate a fully, a full library for this one. We're just making a simple web server. All right, so then we have HTML fs read string. Okay, so we don't need this one. In this case, let's just call, we'll say file name and file name will equals index.html. Let status. So we can also say that status is equal to 200. And you know what I can do? Most of the time it's going to be 200. So I can say that mute status equals 200, and we'll leave this off for this one, and then we'll say status is going to equal 404 here, sort of like change it. Let's go out, let's make it our first big project. I want to make a real thing, like something I can actually use as my first real project. Response equals format. Okay, so I don't want to have to do this now, because we have HTML, we have our status, we don't need this. We're gonna put that down here. So we don't even need the let response up there anymore. Now we're gonna do it down here. Let response equals format. That's where this comes in. basically all of this. Okay, so response equals format HTTP 1.1, and then we're going to put in the code, the status code. So that's being set to this or this, and then okay. Okay, so this one may change around a little bit. This is going to be status text. So we need to also send this as let's mute status text equals okay, but I'm just gonna keep this lowercase. And here we have status, and here it's gonna be status text is equal to not found. All right. Who couldn't use a web server as a project? I think everybody else in the world. There's so many out there right now. All right, so we have status, we have status text, and then we have the HTML. So that means we need to get the HTML too. So let's that will be the next thing. All right, so come here, we have status, we have the status text equals this, the 404, so this is going to be the file name. File name is going to be 404.html, and the response is going to be set up for us. So that actually makes this really simple and a little bit easier to read this craziness in here. All right, so that response equals format. Here we have status text HTML, which means we need. Oh, I deleted the entire part where you get the file, didn't I? That was interesting. So let's do let HTML equals. Did I get FS? FS. Is it like read from file? I think it was read to string path would be the file name. Oh, dot unwrap. Then all of this should happen then. So then we set the response, we write the response out, we flush it, and then we print this line, which we don't really need this line anymore. We're done with that. And this path is just making it easier to write the if statements here. All right, so this should still work. Everything should be fine. And well, we should restart our server. Make sure that everything's still running. So here's our not found. Everything is still good. And if we go to our index, everything is good still. So perfect. We did not break our web server. All right, so what did they do? We did handle connection. Let's see. Let status line file name equals if buffer starts with get. They still have that same get. Then this is going into status line. This is going into file name. I kind of like mine a little bit more. I feel it's a little bit more readable than this. Let contents equals fs read a string. Okay, so we're reading to a string. Let response equals sort of setting this up. Status line and contents. So stream write, response is bytes, and okay. Stream flush, and then unwrap. Perfect. Now the if and else blocks only return the appropriate values for the status line and file name in a tuple. Then we use destructuring to assign these two values to status line and file name using a pattern in the let statement as discussed in chapter 18. The previously duplicated code is now outside the if and else blocks and uses the status line and file name variables. This makes it easier to see the difference between the two cases, and it means we only have one place to update the code if we want to change how the file reading and response writing work. The behavior of the code in listing 20-9 will be the same as that in listing 20-8. Awesome! We now have a simple web server and approximately 40 lines of Rust code that responds to one request with a page of content and responds to all other requests with a 404 response. Currently, our server runs in a single thread, meaning it can only serve one request at a time. Let's examine how that can be a problem by simulating some slow requests. Then we'll fix it so our server can handle multiple requests at once. Turning our single-threaded server into a multi-threaded server. Right now, the server will process each request in turn, meaning it won't process a second connection until the first is finished processing. If the server received more and more requests, this serial execution would be less and less optimal. If the server receives a request that takes a long time to process, subsequent requests will have to wait until the long request is finished, even if the new request can be processed quickly. We'll need to fix this, but first, we'll look at the problem in action. Oh no, the slow Loris attack. Basically, nobody is allowed to hit the server. That just causes problems. So we just need to make sure that nobody can actually use it. Simulating a slow request in the current server implementation. We'll look at how a slower processing request can affect other requests made to our current server implementation. Listing 20-10 implements handling a request to /sleep with a simulated slow response that will cause a server to sleep for 5 seconds before responding. So if I remember right, we use thread and center time duration. So let's see if I can do that before I read that too much. All right, so we need to bring in thread, and so use standard thread, use standard time duration. Okay, so what I want to do is else if why are you trying to force me to do an if let? Okay, so else it's if else. If else if, oh man, I think it is else if. Else if, so buffer starts with path. The location is going to be /sleep as bytes. Is it all one? No, that's not it. Why? Oh, come on. There's definitely else if, right? Expected expression found keyword false. Oh, you know what? I messed that up. You don't have the ending bracket. Yep, you caught it just as I caught it. I was like, why is that not working? It should work. Okay, so if we're starting with /sleep, we want to do thread sleep, then duration from seconds. Let's do 10 seconds, because that will give us plenty of time to actually see the horror of what we've done. And then what we can do is we will we'll just set the file name equal to sleep.html. Could we get the response from the body so we could sleep for that amount of time? Well, so there is no body in GET requests, and so the browser always sends a GET request. I might be able to put in this. Let's put in that print line again. Print line. All right, so what did we have? What was it? It was the stream. Oh no, it was the buffer. Starts with buffer dot read to string, I think. No, that's this one. Buffer dot, can I just do toString? I don't actually know if this will work properly. No method named toString for type U8. It was, oh right, string from. It was string and then from UTF-8 lossy. That's what it was. And then this is the buffer. That was what we can do. So we're gonna do this first. Did I lose? Buffer's still here. Why are you upset? Mismatch types. Expected reference U8 found array. Oh, this needs to be a reference. Buffer is a slice of vectors. Yes. Okay, so we do that. Let's restart the server. If we come, well, okay, we're actually going to run into a problem also because we need to create sleep.html. So that's in, we don't want to do it here. Touch sleep.html. Oh, interesting. So there's Emmet. This is the one that doesn't create it. That's how we got the difference there. Okay, so sorry, I was tired. H1 single threads don't care about your wait time. Okay, so we'll just send this on up. I don't think I need to like restart the server now. Let's go ahead and hit this. So standard, we hit this just fine. Let's also go and make sure that we got a print line. Yeah, so there's our print line. And if we hit this with /sleep, it's sitting here. I don't know if you can see the little back and forth. It's still going. After 10 seconds, we'll get this. Single threads don't care about your wait time. But here's our sleep. So now what if I used sleep and then a route parameter? So question mark, and then it's going to be time equals like 10. Oh, so it actually, so get actually now, unfortunately, it changed the URL, so it wasn't able to find it anymore. What we would need to do, I'm kind of surprised Firefox actually sent around for 10 seconds. Oh, browsers have a really long threshold for waiting when like servers aren't responding. I think it's something like 30 seconds to even minutes. Like it might even be 10 minutes. It's crazy long. How long it will wait. It's usually that like the server will give up way before then, but our server is really stupid, so it just will hang there. Okay, so if I wanted to do this, I would need to write an algorithm, specifically in here, in this path. We get the location string. We don't just blindly put it into here. We would first need to take this reference to a stir and then break it out into the different substrings. So we want to make sure that like we get the ampersands and like, okay, well, there's the path, and so that goes into the location here. But then we have like the other things we have to pass, like return those as well, so we can do stuff with it. That is gonna be a little bit more, that is gonna suck a little bit more. Or the other thing is like up here, we get the buffer and like break it out so that we can, I think that's a little bit more work than I want to do right now with it. I think that's the end result. All right, so we've done that. This code is a bit messy, but it's good enough for simulation purposes. We created a second request, sleep, whose data our server recognizes. We added an else if after the if block to check for the request to sleep. When that request is received, the server will sleep for 5 seconds for rendering the successful HTML page. You can see how primitive our server is. Real libraries would handle the recognition of multiple requests in a much less verbose way. Start the server using cargo run. Then open 2 browser windows, one for HTTP, just slash, and one for, oh right, so that's the other thing we were doing. So when I go to sleep, so if I hit this, now if I go to another one, so localhost 3000, notice that this also doesn't run at all, and that's because it's getting this one first, and this one's just waiting. If you enter the /URI a few times, as before, you'll see it respond quickly, but if you enter /sleep and then load /, you'll see that / waits until sleep has slept for its full 5 seconds before loading. There are multiple ways we can change how a web server works to avoid having more requests back up behind a slow request. The one we'll implement is a thread pool. Improving input with a thread pool. A thread pool is a group of spawned threads that are waiting and ready to handle a task. When the program receives a new task, it assigns one of the threads in a pool to the task, and that thread will process the task. The remaining threads in the pool are available to handle any other tasks that come in while the first thread is processing. When the first thread is done processing its task, it's returned to the pool of idle threads, ready to handle a new task. A thread pool allows you to process connections concurrently, increasing the throughput of your server. We'll limit the number of threads in a pool to a small number to protect us from denial of service attacks. If we had our program create a new thread for each process as it came in, someone making 10 million requests to our server could create havoc by using up all of our server's resources and grinding the processing of requests to a halt. Rather than spawning unlimited threads, we'll have a fixed number of threads waiting in the pool. As requests come in, they'll be sent to the pool for processing. The pool will maintain a queue of incoming requests. Each of the threads in the pool will pop off a request from this queue, handle the request, and then ask the queue for another request. With this design, we can process n requests concurrently, where n is the number of threads. If each thread is responding to a long-running request, subsequent requests can still back up in a queue, but we've increased the number of long-running requests we can handle before reaching that point. This technique is just one of many ways to improve the throughput of a web server. Other options you might explore are the fork-join model and the single-threaded async I/O model. If you're interested in this topic, you might read more about other solutions and try to implement them in Rust. With a low-level language like Rust, all of these options are possible. Before we begin implementing a thread pool, let's talk about what using the pool should look like. When you're trying to design code, Writing the client interface first can help guide your design. Writing the API of the code so it's structured in the way you want to call it, then implement the functionality within that structure rather than implementing a functionality and then designing the public API. Similar to how we use test-driven development in a project in Chapter 12, we'll use compiler-driven development here. We'll write the code that calls the function we want, and then we'll look at errors from the compiler to determine what we should change next to get the code to work. I tried doing this in Windows with WinSock and got to multi-threading, which worked. Didn't get it to render the HTML though. Oh, really? Interesting. I'll be interested to see if at the end of this I can compile to a Windows target and then run it. I have a Windows machine right next to here, and I can in future streams set it up so that like it's showing both monitors, so that way I can like, okay, this guy over here, let's try like now running on there. It will be interesting to see if it works. Okay, so code structure, if we could spawn a thread for each request. First, let's explore how code might look if it did create a new thread for every connection. As mentioned earlier, this isn't our final plan due to the problems with potentially spawning an unlimited number of threads, but it is a starting point. Listing 2011 shows the changes to make to main to spawn a new thread to handle each stream within the for loop. Okay, so we have our standard listener, for stream and listener incoming. So let stream equals stream unwrap, thread spawn. Then we have our closure, handle connection stream. So this is in main here. So if we take a look at what we have here, we haven't been paying attention to main for a while. So for stream and listener connecting, let stream was this, handle connection stream. So we can just throw this into a closure and then basically handle the thread. So it's thread spawn. So let's just try that. Thread spawn. So this is a function, so we don't really need anything there for like the incoming parameters. Damn, got a phone call, have to watch the VOD. Well, thanks for watching, Stacking. We'll see you tomorrow when and hopefully you'll get a chance to read the VOD, but I'm pretty much close to the end too of today's stream. Thread spawn, and then we're just going to handle this connection inside of here. Okay. All right, so thread spawn, handle connection stream. I wonder if there's, as you learned in chapter 16, thread spawn will create a new thread and then run the code and enclosure in the new thread. If you run this code and load sleep in your browser, then in 2 more browser tabs, you'll indeed see that the request to don't have to wait for /sleep to finish. But as we mentioned, this will eventually overwhelm the system because you'll be making new threads without any limit. Do I have to like, I can't remember, does Rest auto close the threads when they're done, or do we have to manually close the threads? With like the thread.join. I think it lasts until the end, but then when I don't remember anymore. But let's actually run this because it is after 7:50, so I don't think I'm going to move it on to this next version until I get this running. So here's our tired. So we're going to hit refresh and refresh, and this just runs right away. We can run this multiple times, and this is still taking a while. In the meantime, we got all these requests that came in, and all the threads were there. So that was perfect. And what we're gonna do is wait until next time to run this part, creating a similar interface for a finite number of threads. So I'm gonna go ahead and update where we're at. So let's do that. how is this rendering HTML? Is this just sending the raw HTML to a client? Yes, that's what I'm doing for this one. So what I have is like sleep.html, index.html, just pure HTML files that I've already created. And then my web server here is reading the file just directly into memory and then just sending that along. So it's a very sort of naive, I wouldn't even say it's server rendered. It's just sending the raw files. All right, so where were we? So created a web server with infinite threads because, well, that's where we'll end. You know what? I bet that would work with Windows too. It's like the rendering. So like if you wanted to write something like Jade or Pug now, which is like another language, and then have Rust convert that into HTML, that's a completely different thing altogether. All right, so coming here, let's close you up. And let's update where we're at. Currently at. All right, creating a similar interface for a finite number of threads. And this is our URL. Okay, so updated where we are currently at. And pushing those up. So the code is now up on GitHub, so we can go find that. Thank you, VS Code. I really don't care for you to tell me that every single time I launch VS Code. All right, so is there anything else that I need to worry about this? I don't think so. So with that, thank you everybody for watching. I'm doing this every single weekday morning at 7 a.m. Mountain Time. I'll be back tomorrow morning to continue working on these threads. As you can see, this is a long page, but we'll just keep on working through it until we have a web server. And when we're done with this web server, I'll see if I can throw it over onto the Windows machine I have next to me and also try that there. I'm also archiving all these videos over to YouTube. And that's what Stacking was saying, that he was going to watch the VOD. And finally, I am, if you want to get notifications when I'm going live, please follow this channel, follow on YouTube for these for those archives. And or follow on Twitter to get the Twitter notifications. I've been trying recently to send out messages like 10 minutes before or so to give a little bit more heads up time. I'm just really terrible at like continuously doing that. So that's why I recommend actually following the channel, because then, well, then that will, you don't rely upon me remembering. And I'm a human and I make mistakes by doing things like forgetting to tweet out. All right, so I don't have anything else. I'm gonna go get ready for the rest of my day, and I hope that you all have a great rest of your day as well, and I'll see you all tomorrow morning for more Rust web server development.